Good morning, ladies and gentlemen. Let's start off with, do you guys know who John Travolta is? Oh, yeah. Well, we've got John Travoltage here today, and we are going to start off, should I start off with his finger close?
No, go back where it was. You know, what you can do is rub his foot on the carpet.
Huh, okay. Oh. Oh. That noise.
Those are electrons.
Ah!
Whoa, he got charged up. Let's see that again.
Let me see if I can move his hand further.
Now move his hand down close. Closer, closer. He's out.
So what's going on here? That is John Travoltage. And we see that, just like with our balloon lab yesterday, right? He was rubbing his foot against the rug, and he was grabbing, and electrons are moving from the rug to his foot, right?
Right, yeah.
Creating that negative charge, okay? And then he got close enough to that conductor.
Yeah.
Electrons flowed. Okay, why does a negatively charged balloon stick to a neutral wall?
Oh.
Okay, so this is our smiley face. Oh. Mr. Boykin, what's the purpose of the smiley face?
So that you know which side you got your hands on.
Okay. And that's important because our hands have grease on them and it will mess with all the charges there.
So now, how do we know it's negative? What would make the balloon negatively charged?
Well, if you guys remember from the video yesterday, this is wool, wool, and that's rubber. And electrons have more affinity or are more attracted to the rubber.
Yeah. And
so when I rub the balloon on here, the electrons don't go from the rubber to my wool, rather they go from the wool to the rubber. It just
so
the rules.
There are excess electrons on the balloon. What does that do to your shirt?
My shirt is now positively charged right here.
Yeah.
And the balloon is now negatively charged right there where it's holding onto the wall.
And what we want to do is, our goal by the end of the day is understand why a negatively charged balloon sticks
Look
to
at
a
him.
neutral wall.
He's falling down.
Says, no.
It's
I wish this room was full of students.
It's better with a smaller balloon. The bigger balloons are a little heavy. Okay.
Yeah.
So we actually have a few words to say here. Okay?
Oh, go back.
I lied.
Oh, yeah.
Okay, so a model is an explanation for an observable phenomenon.
Yeah, so in other words, what's going on with that balloon? Now, here's the deal. We have a model that explains it, but the stuff that the model talks about is too small for us to see, yeah?
Yeah, we can observe what happens. That's the phenomenon that sticks to the wall. But what's going on microscopically, if you will, at the smaller scale.
Right.
And a model helps us understand that. Static electricity. When an electron is placed on an insulator, it stays where it is.
Yeah, we got that yesterday, right? Static means stationary, not going anywheres.
When electrons are placed on a conductor, like when John Travolta touches the doorknob, or he gets close enough, they move around to get as far apart from each other as possible. These are not static.
Yep, they repel each other, and that's a force, and that will push them around.
Mm-hmm. And now we're ready for the lab. Okay, so here we go. Here is our lab handout. This is linked into the Canvas tape. Okay, our electroscope. Step 1, we're going to charge by induction.
Let's see, is that the clean one? No, this is the clean one.
Okay. So we're going to charge by induction. And for the first step, do this with me, right?
Actually, the first one is what?
Charging by conduction. There's a difference. And it says a balloon is charged by rubbing electrons in the cloth. We have our PVC pipe. And we are just going to, charge a balloon by rubbing it a few times. Rub the charged balloon across the knob of the electroscope. And what do we...
Okay, as she rubs and now those are going apart. So on your lab, what should they do?
Describe what happened. Okay, what do you see? What do you observe? Okay, when I touch this to here, Okay, what happened to the leaves? And why did this happen?
Yep, do the best you can on the explanation.
Okay.
So pause the video, do that.
And here we go, step 2. So, should I just start from the beginning then? Or should I just touch it?
No, it's still charged.
Okay, so it says repeat step 1. Well, it's still charged, so I'm just gonna leave it. Then touch the knob of the electroscope with your finger. Describe what happened. Why did this happen?
Wow.
Oh. So you'll notice that, one way you might describe it is that they kind of come together and then flap apart. But the big thing is they're just chilling, okay?
Yeah.
And
so, description and why does that happen?
Yeah.
And do the best you can on that.
But how come they sometimes will come all the way together and then relax?
Momentum.
Yeah, momentum, right? That doesn't really have to do with anything that's actually...
Oh, well, now sometimes they will stick together because these come in like a pack like Post-it notes. And there's a little adhesive on one end, and sometimes they stick together because of the adhesive. But that's not an electrical phenomenon.
Yes, yeah. So, basically it's chilling. It's not being pushed apart. It's not being pulled together. It's just
and we wished you guys were in the classroom. You could do this yourself right now, but such is life, eh?
Okay, keep moving. Step 3. Charging by induction, not conduction, but induction. Okay, so charge the balloon by rubbing it a few times in the cloth, and then bring the balloon close to the knob, but don't touch it. Then I move the balloon away. Okay.
Don't touch it.
See what's going on. Oh, whoa.
No, I heard a click. Here, take it away.
Yeah.
Oh, no.
Good.
Well, no, I don't know. Touch it. See if it's...
Oh, no, it's not. Yeah.
Okay, do that again.
Okay.
So there's a connection between how close the pipe was and how far away they were. So at any rate, what should they do?
Describe what happened. What did you see? I did not touch it. Tell me what happened to the leaves. And make a prediction. Why did this happen?
This is not going to be something we've talked about yet. So the other two we've talked about. We haven't talked about this yet. What do you think's going on?
Okay, make sure something going on there. All right, so step 4. This is gonna be a tricky one. Let's see if I can do it. All right, so bring the balloon close to the knob with the electroscope. So I'm gonna charge it again. I'm gonna bring it close, but I'm not gonna touch it. With your finger, okay, touch the opposite side of the knob, then let go. So I'm gonna bring it close. I'm gonna touch it, and then it says now move the balloon. Oh, and then let go. So this and then this.
Yep.
So 1, 2, 3, 4.
All right.
1, 2.
This doesn't always work, so
I know. We'll see what happens here.
See what happens.
1.
Oh. Take a finger away and then that away.
Did it work?
Well,
I heard the.
Now here's the thing. We can tell if it's charged by touching it. Okay, so when you touched it, it collapsed. So it was slightly charged. Let's do that again.
Okay, here we go. So
And do it quickly. Close, touch.
I know, it's hard. Okay, so I'm going to do one more time.
Well, first of all, let's see. Is it?
Make sure.
Because normally when you touch it, nothing happens unless it's charged.
So bring it close. Touch.
Move your finger, move the bar. And then when you take it apart, if you touch it with your finger, well, you touch it. They move. That's because it's slightly charged. Okay, so challenge. First of all, what did you observe? You bring the pipe close.
Charge pipe comes close.
Touch it with your finger.
Touch with my finger.
Take the finger away, take the pipe away, and then the leaves are slightly apart. So I don't expect you to be able to explain this, but what did you see happen?
Break it down. Think about each step, what's happening. Think about what you know about the charges, and go for it.
Pause the video and just take a look over at what we've just done, and make sure you understand what you observed. The explanation, well, we'll work on the explanation.
Okay. All right. Rocking and rolling. Oh, were we going to do something with this, Boykin?
Sure.
Yeah? Should we do it right now?
Why not?
Okay, let's turn this guy around. Okay.
This is called a Wimshurst machine.
Wimshurst?
Machine. And it works by kind of like rubbing the balloon. It's like a rubbing machine. And what it does, well, just crank it a couple of times. There's a crank.
Oh, gotta hold it.
Yeah. And then 2 counter-rotating discs. And if you crank, whoa, do that again. Whoa.
Whoa.
There's a lightning bolt that strikes. Okay, what's going on is there are 2, these are called Leyden jars, they're like capacitors, whatever that is. And what this does, it pulls electrons out of one jar and puts them in the other. So this one's missing electrons, what can you say about it?
Positive.
This has got a buttload of electrons in it, what can you say about it?
Negative.
And so you get so many electrons built up that after a while, does air normally conduct electricity?
Not usually, no.
No, that you'd walk by the plug socket in your house and the
And
electricity jump out and bite you. So crank that sucker again. Let's see.
Okay, here we
this
go.
here.
Come on, there we go.
Sweet.
There we go.
Now,
Yes.
air does not normally conduct electricity, and there's something called a potential difference between one side and the other. It's about 30,000 volts.
Yikes.
Yikes.
Okay. No,
Yikes
but
indeed.
do you always leave that up then?
It doesn't matter.
Yeah.
Once these are touched together, it won't bite you. It will bite you, and Mr. Boykin has sworn in class when that happens.
Okay, so charging by conduction. This is review. Happens when a charged object, like our PVC pipe or balloon, touches an uncharged object, like our electroscope, and transfers electrons.
Yeah, so that's what's happening here, right there.
Oh yeah, look at that, right? These electrons this is charged, and it transfers them to here, and they spread out to the
So
bottom.
you've got all those electrons that repel
Now,
each other.
how come they go all the way to the bottom? Because they're trying to get away from each other, right?
Yeah, there's a
Right.
force of repulsion that drives everything.
Yeah, trying to get as far away from each other as possible. And what do we observe when we see this? Well, our leaves, it's hard to see here, but they come open.
Yeah.
Oh, anything for that one, Boykin?
Well, that's basically the one on the left there is touching the finger. That's
Oh, grounding.
grounding.
Yeah. Oh, and here we are, grounding. Electrons move into or out of a large reservoir of charge. For example, the Earth or you, which is why you can touch the electroscope and we're grounding it, right?
Yeah. And you don't feel anything because you're a
No.
large reservoir of charge. There
Yeah.
are many, many atoms inside of you.
Yeah.
And grounding can work in both directions. It can let electrons go out or it'll let electrons go in, depending.
Sometimes when I get out of my car to go put gas in it, I will touch like my metal handle,
Yeah,
and I get that shock.
that's a good
right?
thing. You know,
Yeah.
because static electricity sparks at a gas station are dangerous. You can start a fire.
Okay. So would I be? So is my handle grounding me then, or is we don't know? It's
Well,
complicated.
you slide across
Yeah,
the seat, and you have different materials, and electrons are transferred from one to another. So you've got a
depending on the
charge,
electron affinity.
and so you touch the handle, the metal, and it grounds you.
Okay, charging by induction. I don't know if our kids drive yet. Maybe they do.
Some of them.
Charging by induction. Aha! This was that third step. Bringing a charged object close to a neutral object causes electrons to move inside the neutral object.
Yep. And that's what we saw. There's no touching. It's
touching.
just you just persuading electrons to move away.
Yeah, there's some sort of induction. We haven't talked about this word induction yet. Okay, should we say it for the video?
It comes from the word induce, which means to persuade.
To persuade.
That's right. You know, it's like
Oh.
you can go up to somebody and you grab them by the shirt and you say, "You come over here and help me."
Help me
And
now.
you'll probably piss them off, and they're not going to do it. But if you say, "Hey, come over here and help me, I'll give you a Snickers bar," that's persuasion. That's inducing. That's induction.
I'm imagining, when your guys' parents say, do the dishes now, and you're like, you really don't want to do it. But then when they're like, I'll give you can go hang out with your friend if you do the dishes. So, I don't know. I'm trying to persuade you. Anyways.
Chocolate works for me.
Yeah. It's like, what do you guys even hang out anymore? I don't know. You get 20 more minutes on your iPad. Okay. All right. So, and we have a video here for you, and you guys are gonna go ahead and watch this. And are we gonna have another thing for them?
Yeah,
to do?
we'll have a little video so that to help them stay awake during the video.
All right. So it's hard because this stuff is so we can't see it. So these videos really helped me, help you guys learn more.
Yeah.
So lab today, and then the guided video handout.
Cool.
Okay.